Today, we will take another set of numerical problems on electrostatics. My request is to please refer my previous lectures on how to solve numerical problems in physics and numerical problems in electrostatics set 1. So this is set 2. We will see few problems on electrostatics. So first problem is two protons with position vectors 2i plus j minus 2k and minus I plus 2j minus k are situated in space. The Coulomb's force between them is. So here only magnitude is asked. So your time starts now. You may try yourself to find the Coulomb's force between two protons having these vectors. So your time is coming up. Yes. So answer is 2 into 10 to the power minus 29 newtons. Let us see how this answer comes. This is the problem. Solution starts with our concept. So this is the diagram where the two charges are situated in space with position vectors r1 and r2. Then the force on q2 by q1 is given by this formula. And here the given is q1, q2 are 1.6 into 10 to the power minus 19 coulomb as they are protons. R1 is equal to 2i plus j minus 2k. R2 is equal to minus I plus 2j minus k. So here R2 minus R1, that is vector from q1 to q2 is minus 3i plus j plus k. So the distance between q1 and q2 is equal to under square root of 11. So here the formula we use only for magnitude 1 upon 4 pi epsilon 0 q1 q2 upon r square. If you put the values and solve it, you will get the answer like this. As I have already suggested to separate the powers of 10, and you solve the separate powers of 10 and you just calculate the numerical values only. That is 9 into 1.6 into 1.6 comes out to be 23.04, and square root of 11 square is 11 only, and answer comes out to be nearly equal to this much. If you find if you want to find the force in vector form, the formula will be like this and you will get the answer like this. Okay, so let us see the next problem. The electric field intensity due to an electron at a distance 1 meter in vacuum is. So here electric field intensity is to be found. So your time starts now. A simple formula you have to use. E is equal to 1 upon 4 pi epsilon 0. Q upon r square is the formula. And here the charge is of electron. So yes. So the answer is minus 1.4 into 10 to the power minus 9 Newton per coulomb. So let us see how this problem is solved. So here the concept, as I said, electric intensity is equal to, this is the formula in vector form, and in magnitude form it is simply E is equal to 1 upon 4 pi epsilon 0 Q upon r square. So here given is 1.6 into 10 to the power minus 19 coulomb is the charge of electron. Distance is 1 meter. So this is the formula, and if you put the values, the answer comes out to be like this, and that can be expressed as minus 1.44 into 10 to the power minus 9 Newton per coulomb. Third problem, two electrons are held 3 micrometer apart. When released from rest, what is the velocity of each electron when they are 8 micrometer apart? So here these are the options. So you may try that. So initially they are at rest at 3 micrometer away, and due to repulsion they move away from each other. And here we have to find the velocity when they are 8 micrometer apart. So here the problem is little bit lengthy, but you may try that. The answer comes out to be 7.2 into 10 to the power 3 meter per second. So let us see how to solve this problem. So here these are the two electrons which are 3 micrometers away from each other. Here they are with the potential energy is say E1, potential energy E1. Here the concept is the potential energy is equal to potential, electric potential into charge. That is, electric potential is given by 1 upon 4 by epsilon 0 q by r, and potential energy will be equal to 1 upon 4 pi epsilon 0 q by r multiplied by charge. Okay. So either here the charges are same, therefore I kept it as a q and q only, and total energy is equal to potential energy plus kinetic energy. Now what is given? Charge is given, distance, first distance is given, second distance is given, r1, r2. M1, that is M is the mass of electron, that is 9.1 into 10 to the power minus 31 kg. Here in the second situation where electrons are apart from each other, they are repelling each other, therefore they are moving away from each other. So they will have the velocity in opposite directions. Here for the second situation we say potential energy 2 plus kinetic energy. In the first condition there is only potential energy because the two electrons are at rest. There is no kinetic energy in the first case, and in the second case both kinetic energy and potential energy is there. So as I said, the potential energy 1 is converted into the potential energy 2 plus kinetic energy. So here the potential energy 1 is given as like this, and kinetic energy of electron is half mv square, and potential energy is 2 given as this, because the distance between the two electrons in the second case is say r2. So here the potential energy 1 is equal to potential energy 2 plus kinetic energy. Therefore kinetic energy is equal to potential energy 1 minus potential energy 2. So therefore this is the equation mv square, because the kinetic energy of first electron and kinetic energy of second electron both are added, and it is equal to mv square. Therefore our formula becomes like this. So the answer comes out to be mv square comes out to be is equal to 4.8 into 10 to the power minus 23, and v square is equal to 0.527 into 10 to the power 8, and v is equal to finally 7.2 into 10 to the power 3 meter per second. Yes.